Chapter 11, Section 2 in the 7th grade note-taking guide is entitled Experimental Probability. Experimental probability is the ratio of the number of times an event occurs compared to the total number of trials. What you need to know is there's two different types of probabilities: experimental and theoretical probability. And we'll get to theoretical probability soon enough. But this is experimental probability. As you can see in the word experimental, you see the word experiment, because that's what experimental probability is based on. Experimental probability is based on me actually doing an experiment. I have to go try and do something. And when I try it, whatever those results are, equate to whatever my experimental probability is going to be. Theoretical probability is just based on the numbers. It's not based on me actually trying something, proving something. It's just based on the numbers and the situation I give you. For instance, if I said, what's the probability of getting heads on flipping when we flip a coin, you know that the answer is 1 out of 2. How do we know that? Well, we know that because there's 1 heads on a coin and 2 possibilities. So that's how I come up with 1 out of 2. So if I said, okay, I flip that coin 20 times, how many times is it going to land heads? Well, because it's equal to a half, you're going to say it's 10 out of 20. Makes sense. But now I'm going to go actually flip that coin 20 times. And let's say 13 times it lands on heads. Well, that's not theoretical probability. That's experimental probability. Why? Because I actually went and tried it. I flipped the coin 20 times and 13 times it lands heads, so I say it's 13 out of 20. That's what experimental probability is all about. It's based on me actually going and trying whatever it is they want me to do. Alright, so number 1. During skating practice, Sasha lands 7 out of 12 jumps. What is the experimental probability that she will land her next jump? Well, let's look at what the question says. The question says here that she's going to make 7 when she tries 12. So what's going to be the probability of her landing a jump? Well, based on those numbers we already have, experimentally, it's 7 out of 12. How did we come up with that? Well, it's the number of times whatever we want to happen happens. 7 times she landed the jump compared to the 12 times she actually tried it, the total number of trials. So here we're comparing the total number of jumps she landed and the total number of jumps she attempted. We write that as a fraction and we end up with 7 out of 12. So the probability of her landing her next jump is 7 out of 12. Now, one of the things they're going to ask you to do in the homework tonight is they're actually going to ask you to write that as a decimal and as a percent. And that's real simple. You're going to start off and you're going to divide. You're going to divide the 7 and the 12 to get a decimal. You know how to do that. We've done fraction to decimal. Once you get that decimal, you're going to change that to a percent, because that's the other thing they're going to ask you to do. Remember, you move the decimal 2 times to the right and add a percent sign. Students have checked out 55 books from the library. Of these, 32 are fiction. What is the probability that the next book checked out will be fiction? So in order for me to write a probability that is about the number of fiction books checked out, I need to compare the number of fiction books that have been checked out and the total number of books that have been checked out. Well, that's all given to us in the prompt. The question says there are 32 fiction books checked out and 55 total books being checked out. So the probability of a fiction book being checked out, based on that scenario, is 32 out of 55. So the probability that the next book checked out will be fiction is 32 out of 55. Students have checked out 55 books from the library. Of these, 32 are fiction. So we're using the exact same prompt. But now the question says, what is the experimental probability that the next book checked out will be nonfiction? Well, we can come up with the nonfiction here because the situation they give us describes complements. Now, complements, if you recall, that's a vocab word from Chapter 11, Section 1. That describes the only 2 things that can happen, 2 things that make 100% of the possibilities. Well, all we've got is fiction or nonfiction. So that's all the choices. So if we know there's 32 fiction checked out, everything else has to be a non-fiction book, which is good because this question is all about the number of non-fiction books we check out. So to find the probability here, we're going to compare the number of non-fiction books we checked out, 55 minus 32. How did I come up with that? 55 total books minus the 32 fiction. Again, everything else had to be a non-fiction book. And we write that fraction to compare it to the number of total books checked out, which is still 55 like it was in the Part A part. So we write our fraction there, and that's going to equal 23 over 55. So the probability that the next book checked out as nonfiction is 23 over 55. All right, so during basketball practice, Martha made 9 out of 10 free throws. What is the probability that she will make her next free throw? Well, it says she's making 9 out of every 10. So the probability for making a free throw is 9 out of 10. Students have a fruit choice for lunch of an apple or a pear. So far, 18 of 47 students have selected the pear. What is the experimental probability that the next fruit selected will be an apple? All right, so again, just like the earlier question about the library, what's described here are complements. There's only 2 things that can happen. I can pick an apple or I can pick a pear. We've got 47 total students we're looking at, and it says 18 of them have selected the pear. So how many of does that mean then would have selected the apple? Well, if 18 selected the pear, and there's 47 total kids, that means the other 29 had to have picked an apple. So what's the probability of picking an apple? Well, there's 29 apples picked compared to 47 total apples. So that's 29 over 47.